Problem 697. What values must x have so that the log of x is greater than 2? Justify your answer. So for this problem, we're looking at if we have the log of x, they want to know when is this going to be greater than 2? What values of x must we have here? Well, let's start out by looking at what if the log of x equaled 2. Remember, this is what we call log form. Let's go ahead and put it in exponential form just in case anybody's a little confused. Let's go to exponential form. So our base, when we're doing just log, remember, is 10. We just don't write it in there. So we'd actually have 10 to the second power would equal our value of x. In which case, for this particular example here, when it equals 2, let's say when log of x equals 2, then then the value of x has to be 100. So if we're trying to come up with a way to represent when we're going to have values that are greater than 2, then we need to think about other situations. For instance, here, if we had, say, the log of x, let's say it was equal to 3. If you think about what that would be in exponential form, would our value here, 10 to the third power, would equal our x, and you'll see here that x would end up equaling 1,000 in this case. So notice our values of x have increased here. So any value of x that we have here that is greater than 100 should equal something more than 2. Let's write that. Any value of x greater than 100 should result in the log of x being greater than 2. Okay, let's look at some different ways to kind of see this or to check it over here. I'm going to get out my calculator. Let's see if I squeeze it in over here. So we're saying here any value of x that's greater than 100 should result in the log of x being greater than 2. Let's check it here. Let's do the log of, say, simply 101. That should equal a value that is greater than 2. If we continued going up there, this value would just continue to increase, higher and higher. If you wanted to look at it from a graphical standpoint, let's graph the log of x. Okay, so if we graph our log of x, and let's look at, let's look at our graph first. You see it goes up here. So we want our output to be greater than 2, so it looks like it's going to be, getting close to 2, but let's go here and look at our table. So we want to know when is our output here going to be greater than 2. Well, you see how small these are, but they are growing. So as we scroll down, you'll see here, we're at 1. So when we put in the log of 10, it would equal 1, and then we go on and on and on and on here. So what we'll see here is once we get to, let me just jump in here and jump ahead a little bit. You see, once we get all the way up to where we're putting in 100, that's where it equals 2. So anything less than 100 was less than 2. When we put the log of 100, we said it was equal to 2, and we figured that out. That was fine. But then as we go over it, everything above there is going to be more than 2. And then we look at, let's go ahead and look at our table here. I'm sorry, our graph. Let's go ahead and increase this to our x max to say 200. And let's go by tens. So let's go second. We don't do second there. Let's just do. So as we look at here, it continues to go up and up and up and up. Here's where it's going to equal 2. So right about there is where we end up equaling 2. And then everything above there. So all these values, remember these are going by 10. So this should be about 100 here. And then everything above gives us a value greater than 2. Hopefully this helps to clarify or helps you to see what's going on in this problem. This is problem 6-97. If you still have questions, make sure you look to get some help. Thanks for watching.